Matgum tutorials, an investment in knowledge pays the best interest.
Hi there, you're welcome to Mackin Tutorials, your best online tutorial center. At Mackin Tutorial, we are dedicated to giving you the best tutorials through this our YouTube channel. Today, we are going to look at WASSCE, that's the West African Senior School Certificate Examination for school candidates in 2018, and the subject we are going to solve is Physics 2. That is the essay part of the physics. This part is divided into two parts, parts 1 and 2. And for the purpose of this tutorial, we are only going to solve part 1. In our next video, we will show you the solution to part 2. So let's get started. The first question there is this: define strain. Strain is the distortion or change in dimension of an object as a result of applied force. Or you can say it is the ratio of the change in dimension of an object to the original dimension, or the ratio of the extension of an object to the original length. Now the second question: a rubber band is stretched to twice its original length. Calculate the strain on the rubber band. From the question, the original length of the rubber band, let's call it L, and then the rubber band is stretched to twice its original length. That means the extension of the rubber band is equal to the present length, which is twice the original length, yes, minus the original length. That is the extension. And the formula for strain is equal to extension divided by the original length. So if this is our extension, then the strain is going to be 2L minus L divided by L. Let me move this up a little bit. 2L minus L is L. So we have L divided by L. So the answer to this question is 1. That is the answer. Now let's go to the next question. State 3 materials used for making optical fibers. If you remember, optical fibers is actually a material that uses the process of total internal reflection, and then it is used in telephone cables, is used in broadcasting stations and the like. So we are asked to state 3 materials used for making optical fibers. Here I have stated 5 materials, so you can just pick any 3 of those materials: fine strands of glass, polycarbonate, Teflon sheets, silica, and sapphire. So we go to the next question, and that will be number 3. Number 3, name 3 classes of magnetic materials. Now we have paramagnetic materials. I'll quickly give you a brief explanation or definition of paramagnetic materials. These are materials that are not strongly attracted to magnets, for instance, aluminum, zinc, or magnesium. Now the second one, we have diamagnetic material. They are materials that are actually repelled by magnets. For instance, we have mercury and lead. Then the third category, I know you are conversant with this, ferromagnetic materials. These are materials that are strongly attracted by magnets. Of course, you know iron is there, you know zinc, steel is also there. Now let's go to the next question, that is number 4. What is an intrinsic semiconductor? You know that we increase the conductivity of a semiconductor by adding impurities to it. But when we have a semiconductor that is in its pure form, it is called an intrinsic semiconductor. So this is a semiconductor that does not have impurities added to it. and it has the same number of holes and free electrons. Now, the B part of the question: distinguish between the p-type and n-type semiconductors. I have written here: one, the major carriers of electricity in p-type are the holes, and in n-type the major carriers of electrons are the major carrier of electricity are the free electrons. Now, for the p-type, p for positive, it has a net positive charge, and n-type, n for negative, it has a net negative charge. Now, p is created by an acceptor impurity, while the n is created by a donor impurity. P-type impurity is trivalent. That is, the doping for p-type is done by using a trivalent element. By doping, I mean the process of adding impurities to semiconductors. For n-type, the doping is done by a pentavalent element. Question 5. A missile is projected so as to attain the maximum range. Calculate the maximum height attained if the initial velocity of projection is 200 meters per second. Now take acceleration due to gravity to be 10 meters per second squared. The formula for the range of a projectile at the maximum value is u squared sine squared theta divided by 2g. I need you to take note of this sine squared theta because that is where students make a lot of mistakes. As we go on, I will explain what I mean to you. So for the range, the velocity given is 200. So u squared, that is 200 squared, which that's 200 times 200. Now, sine squared theta, what I mean is this. We have been given, what is the angle given? Okay, at maximum height, the angle is 45 degrees. At the maximum height, at the maximum range, the angle is 45 degrees. So we have sine 45 squared. You first calculate the value of sine 45 like this, and then you square it. That is what is meant by sine squared theta. Then divided by 2 times 10. Now, if you do your calculation, 200 times 200, and I think that is 40,000, you calculate sine 45, then you square it. When you multiply this and you divide by 20, you get 1,000 meters. 1,000 meters. So that is our answer. Let's go to the next question. Now the next question, that's number 6. Let's check what we have there. A black body radiates maximum energy when its surface temperature T and the corresponding wavelength maximum are related by the equation this. Now, given the values of the constant and surface temperature as this and this respectively, the constant is this, the surface temperature is this. Calculate the frequency, okay? Now, from this formula, we have that, the maximum wavelength will be equal to, let me call the constant K, constant divided by temperature. So what is the value of the constant? The value of the constant is 2.9 times 10 raised to the power minus 3. So we have 2.9 times 10 raised to the power of minus 3, the power of minus 3 divided by T. Our T is 57. 57. But if you look at this unit is given in meter Kelvin. So we have to convert this temperature to Kelvin. By converting this temperature to Kelvin, we add 273 to 57, and that gives us 330. 330. 330. Okay, if we now do this calculation, our wavelength will now be equal to 8 8.78 times 10 raised to the power minus 6. 8.78. You can do the calculation and confirm. Times 10 raised to the power minus 6. Okay, and what's the unit? The unit is meter. The unit is meter. We've only calculated the wavelength. What we are asked to calculate is the frequency. Remember this formula? V equals F lambda, where V is the velocity, F is the frequency, and this one is the wavelength. So if we are to calculate this, we now have that frequency is equal to velocity divided by wavelength. And the velocity here, because we're talking about radiation, so the velocity here is actually the speed of light, which is 3 times 10 raised to the power of 8 meters per second. So we now have it as, let me raise this one up a little bit. We now have it as, which is equal to 3 times 10 raised to the power of, 10 raised to the power 8, yeah, divided by, what do we get as the wavelength? 8.78 times 10 raised to the power of minus 6. Minus 6. So if we do this, if we calculate this, it gives you 3.4 times 10 raised to the power of 13. And what is the unit of frequency? Frequency is measured in hertz. So this is our answer. So simple. Let's go to the next one. What does the acronym LASER stand for? Some of you may not know that the word laser is actually an acronym. So it stands for Light Amplification by Stimulated Emission of Radiation. The second question is a related question. A laser, what is a laser? Now, a laser is a device that emits a beam of coherent monochromatic light through an optical amplification process. The word monochromatic here, monochromatic, means light of one wavelength. That is when it passes through a prism, it comes out with the same wavelength. Okay, now we have come to the end of the first part of the SSCE 2018 physics essay question. I believe you have really enjoyed watching the video, so I will advise you not to forget hitting the subscribe button. It's just a way of saying thank you for teaching me this, and then turn on the notification bell icon so that you get notified anytime I post a new tutorial. Do not forget, wait for the next one. In the next video, I am going to solve the part 2. Thank you so much, and bye for now.